Our first step is to choose our values for a dependent variable, or independent variable. We're going to choose any 3 values for our independent variable. In this example, it doesn't make sense to use negative values because someone cannot be working on your telephone line for -1 hour. So we'll use the values 1, 5, and 6 for H. Step 3 is to substitute to find values for the dependent variable. So here we substitute our value of H into the equation. So we have C is equal to 90 plus 32 times 1 hour for a total of $122 as the cost of repair for 1 hour. We then take our value of our independent variable and our dependent variable and put them together in the coordinates column. You can see that we've done this for points 5 and 6 as well. For H of 5, we've substituted to have C is equal to 90 plus 32 times 5, or C is equal to 250. So the coordinate that goes along with that is at 5 hours worked, the cost is $250. And for H of 6, we have C is equal to 90 plus 32 times 6, equal to 282. So the coordinates for that are 6 and 282. We can see a scatter plot that we can generate from the coordinates we've just found. Here we have the independent axes represented by our hours worked and our cost of repair represented on our dependent axes. We've chosen a scale that has allowed all of the points to be within the graph, and we've given it an appropriate title, telephone repair rate. In the previous example, values for the independent axes were chosen randomly. Most often, you should take a more organized approach. You can learn a lot from a table of values if you increment the values for the independent variable by the same amount each time. Let's take a look at an example. Given the equation y equals 2x plus 2, create a table of values. The first step is to set up our table with our headings x, y, and our coordinates. Go ahead and fill out the table of values. When you have it completed, come back and see if your response matches